Home inspectors should look for and take note of steep slope. The home inspector should note if a home is on a steep slope and, therefore, subject to erosion or movement. The maximum slope of a lot should be roughly 1 and 2. Negative grading. The home inspector should note if a home is subject to negative grading or poor drainage. Water penetration could damage the foundation over time. Also, take note of driveways that slope toward the home. High grading. Wood siding and sill plates should be at least 6 inches above grade. Rotten sills will be crushed by the weight of the home and lead to settlement. Furthermore, a rotten sill weakens the anchoring of the framing to the foundation.
The home inspector should note if the downspouts for the guttering system are discharging too near the foundation.
4 to 6 feet is normal.
The inspector is required to report vegetation growing near the home, according to the home inspection standards of practice. The home inspector should note the existence of any trees near the home, because the roots may affect the foundation or underground drainage pipes. Plants growing next to a house could raise the soil level too high against the foundation.
Home inspectors should look for and note mortar joint condition, loose bricks, misdirected downspouts, overflowing gutters, horizontal cracks, vertical cracks, step cracks, untreated wood in contact with soil, previous repairs, sagging lintels, missing or obstructed weep holes, too few weep holes, and missing or improperly installed flashing.
So I'd like to take a few moments on this slide and talk about the different cracks that we're seeing here. The first one let's start off with is this window up here. Now, whenever we have a brick siding on the building, typically we're going to have a steel lintel up along the top of it. Now, those steel lintels, they go about 3 to 6 inches to the left and to the right of the window. One thing to know about steel is that it expands. Steel expands when it rusts. So when water gets into these things, they're going to end up getting bigger. When you see the cracks stepping up like this, that usually means that there's an upward pressure that's being pushed on it. Once the lintel fails, so eventually it's going to keep rusting and getting worse and worse. And most of these lintels take I'm guessing 30, 50 years. It's a very long time. But once that happens, and I'll use the next window here, then you're going to get this sag happening right in there. When that sag happens, that step cracking, now that creates a triangle over the top of the window coming back down on here. At this point in time, that lintel failed. And even you'll get a lot of brick masons in here that when you get that crack going straight up there like that, then they're going to tell you that that's also failed. But in the meantime, whenever you just see a straight crack left and right, like on the window like this one here, that is rusting. It's just pushing out the mortar. But I don't know, this is my opinion, our company's opinion, and most home inspectors I know, this does not warrant replacement. When you get the angles like this or going over the top, then those do go ahead and warrant replacement. Let's take a look down low now, and we'll talk about the settlement cracks that are happening. All this fill that they're showing in here, they're saying that that's poor bearing earth. That's what's on there. So whenever you see these cracks going on an angle like this, you want to follow them down to their last point of support. All right. And everything underneath it is kind of dropping, is what they're trying to show here. All right. So the last point of support is going to be right along here where those X's are. All right. If it's heaving, and that may happen too, it could be pushing up on this Sometimes, like in the previous slide, it showed that tree trunk. And if the tree roots get up underneath there, they'll just push everything right up. That could also cause the same thing. So think of everything below that crack going down, or everything above that crack going up.
There are many areas of the gutters and downspouts that a home inspector may observe. Home inspectors may report upon observed indications of overflowing clogged gutters, but it's not required according to the home inspection standards of practice.
Proper slope is going to be 1 in 200. I think that shows up on a test question, so you're going to want to write that one down.
A vertical foundation crack could be due to serious settlement if it is significantly large or shows signs of ongoing movement. If the cause is shrinkage, it is of less concern than if the cracks are a result of settlement. Vertical cracks are not typically known to be caused by frost dirt that is up against the foundation.
So for our company, whenever we call out serious cracks versus minor cracks, anything that's greater than 1/4 of an inch, we're going to consider that serious. You'll see a lot of home inspectors, they'll go all the way down to 1/8 of an inch. There's no real set stone. You're going to have to choose what you want to choose. But really 1/4 inch, and I should say equal to, so it really is the same, equal to or greater than 1/4 of an inch. If a crack was repaired and it came back again, we consider that a serious crack. If it goes in 2 different directions, so as we're looking at this crack right here, we could see that, let's go across the top. We know that just because the crack happened, it's separated right there. So if one side came forward or one side went backwards, or maybe it sheared, so it went like this side went down and this side went up, we would consider those serious cracks. So 2 directional movements. Repair came back, 2 directional movement. And the last one is kind of simple. Anytime you see any sort of light shining through it, that's legitimate. Now, we always take a big concern when it comes to water leakage coming in here. So that's where we're going to be looking for water stains around the crack on both sides. One of the things we're looking at in this slide here, oops, sorry about that. One of the slides we're looking at in this picture here is for a structural engineering evaluation. These guides that they put on there, it gets adhered to the actual foundation. And this takes about 6 months to get this taken care of. And they're going to measure how much it's moved, the weather conditions, and other things that come into play during that time frame. We don't have that luxury of 6 months when somebody's buying a house. So we kind of have to come up with some sort of rules. Now, it's very common where home inspectors will say, hey, listen, I think this is serious. If you want to know more, this is over my head. You're going to have to get a structural engineer, all right? But I think it's also fair to tell our clients that if they're going to do a true structural engineering evaluation, then they're going to be putting one of these measurement things on here, and yeah, and that just takes a long time. So most structural engineers are going to use basically the same rules that we use. And if it's over 1/4 of an inch, if 2 directional movements, if it's been repaired and it cracked again, which means it's still moving, then we need to go ahead and get a foundation repair company out there. And a lot of times they'll tell you, just to be safe, you're better off getting a foundation repair company out there anyway.
Diagonal cracks that grow in width, especially ones that are wider at the bottom than at the top, indicate settlement. Diagonal cracks over windows indicate a weak header. Diagonal cracks in a poor concrete foundation that are fairly uniform in width or are hairline type are caused by shrinkage, and though they may allow water entry, do not constitute a structural defect.
Now, these horizontal cracks are usually pretty serious. We're going to want to be aggressive on those, especially when there's any bulging. In other words, if this line is moving inwards, then that's bad, all right? No ifs, ands, buts about it. When you get a straight up and down vertical crack, like what we're showing on this one, that's usually trauma of some sort. These step crackings here that we're seeing on the number 3 spot, that's usually settlement or heaving, one or the other. And then down here on the bottom too, this is also the shear crack down here. That's also some sort of trauma. Something's pushing it in here. Now inside corners, let's see if I could shrink this up here. No, I guess I can't. So inside corners, so if I'm taking a bird's eye view of a basement floor like this, whenever I have these inside corners like this, because concrete shrinks, these cracks come in here quite often, all right? Same thing if I had a post in the middle. Sometimes you'll see some spider cracking going off. You might even see one crack going to another corner in the floors. That's all normal. When you see corner pieces like this is usually an indication of settlement going on here. And then usually we're going to want to look at the surface drainage. So if I saw settlement here, I would be looking for downspouts that are discharging right outside that corner. If I see a crack going all the way across, I'll probably have a settlement crack up the walls like that. And that usually indicates that I'm going to have a ground or driveway or sidewalk, something sloping towards the house, which is causing that whole area to drop down.
A crack that forms a V shape may indicate heaving. The illustration above shows a V-shaped open crack in a foundation wall indicating heaving from the ground under the foundation footing. The ground in the illustration is expanding and pushing upward on the footing and foundation, causing a crack. This observation by a home inspector would be reported as a major structural concern and defect, with correction and further evaluation by a structural engineer as a recommendation in the report.
An open crack that forms an upside-down V or pyramid shape indicates settlement or drooping in the middle.
Horizontal cracks are not caused by settlement, yet they can still be a cause for concern. Horizontal cracking is caused by pressure on the outside of the foundation wall below grade. Most often, the cause is improper backfilling, but expansive soil and frost are also possible causes. Horizontal cracks are often accompanied by lateral displacement, meaning that one side of the crack is pushed in or out further than the other side. In time and depending on conditions, the wall may begin to bow in and even collapse.
So one of the cures and one of the repairs that we're looking at here are these I-beams or pilasters, whatever you want to refer to them to. But these get secured at the top and also down at the bottom. And that's to basically prevent the wall from being pulled in. It also takes some of the weight off the house. Now, these do have to be designed by a structural engineer. Foundation repair companies usually have structural engineering drawings that are set up with these things so they know how far apart they have to be put into place in order for them to do their job. And there should be some sort of paperwork that comes with it. All right. So it's not up to us to say that it's okay. And one of the things I like to preach to the guys that work for us in our company is don't let somebody else's problem become your problem. All right. It's not my job to determine if this is okay or not okay. Somebody else designed it. They're the ones that are going to be responsible for it. We just have to advise our clients on that.
The crack has been patched and has opened up again. The edges of the crack in brick are sharp and not rounded with time. There is no dust or debris inside the crack. The wall is painted, but there is no paint inside the crack. The longer a crack has been there, the less of a structural issue it is.
And again, the main thing is to find out if it's still moving. That's our main goal, to see if it's still moving.
Some inspectors think that if a crack follows the mortar joint rather than going through the brick or block, the crack isn't a problem. This is false. Walls crack at their weakest point. If the mortar is stronger than the brick, the wall will crack through the brick. The crack in the mortar joint should be repaired and monitored for indications of an active crack.
Okay, so on this drawing here, you can see, or this picture, we can see how it's kind of narrow here and it's getting wide there, then narrow, wide. This whole section is either moving this way or this section is moving that way. So again, we're shearing, we're not just pulling apart. All right.
The end of an I-beam pokes out through the wall. The overhang of the brick veneer is most pronounced near the middle of the wall and then disappears at the ends. Up to a 1-inch overhang is considered acceptable.
Yeah, so what we're looking at on this foundation wall is just bad. We obviously have a horizontal crack. Everything's coming inwards. This is called bulging, like this. Whenever the foundation wall, like if it comes in and then goes back out again, that's called bowing. But when it's a vertical movement, it's kind of like your knees bending. We call that bulging. So things that we'll see on the outside, that the brick veneer, or if it's true brick, that should be uniform from one end down to the other. If something's pushed in, then that again is pretty serious. This is way over our heads. You know, this is a red flag, and we need to get a foundation repair company out here as soon as possible.
When an attached garage slab heaves or settles, it will often pull away from the home and leave cracks.
Block foundation walls are often parch coated on the exterior. This base and finish coating is a mixture of Portland cement and sand and is applied to give a smooth and uniform appearance to the foundation's exterior. Often, moisture gets behind this parch coating. In the winter, through freeze and thaw cycles, the moisture pushes outward at the coating, causing it to crack and crumble. This should be noted by the inspector.
So, and the parging, I'd like to expand on that a little bit. We don't put it on just for decoration. This is also draws the moisture out of the wall when it comes to it. The parch coat is sacrificial. So this is designed to fail over time. Sometimes it's 5 years, sometimes it's 10 years. Sometimes it'll last a lot longer. We just don't know, all right? So it's not to be alarmed when it's there. You know, the mason guys come by there and they'll just shmooey some more stuff on there and just make it look nice and clean again. And it is something that your client should be prepared that they're going to have to do. And if you're going to guess every 5 years. If it's longer, well, then that's great. You know, we just don't want it to be shorter for them. All right.
A brick wall is not necessarily considered to be waterproof. Water can penetrate through a masonry crack that is hairline, or as small as 1/100th of an inch, 0.3 millimeters. The masonry exterior covering materials, siding, is porous and can absorb moisture during a weather event.
Usually they're installed every 24 to 32 inches as we're going, you know, along the wall. So basically what they're saying is water gets trapped in between here. You know, brick is porous, mortar is porous, you know, so when it rains, it gets in there. Sometimes we'll have a difference in temperature. It's going to be 70 degrees here and 10 degrees outside, all right? Or even with air conditioning going to be vice versa. So we're going to end up getting condensation forming in here. We have to give that way, that condensation, we have to give it a way to escape. And that's what weep holes do, all right? We're going to find them on brick veneers, which is what we're showing here. So this is a wood frame structure, all right? And then this is a single width brick wall, W-Y-T-H-E, width brick wall. And this is decoration. This single width brick wall has no structural support whatsoever on here, and it's the same as aluminum, vinyl siding, whatever, just decoration, and that's it.
Home inspectors should take note of who built it, missing or loose fasteners, the condition of fasteners, a lack of fastener nails, the use of untreated wood, whether the deck is pulling away from the house, wobbly rails or unsound steps, and rot especially where cantilever joists penetrate the wall. Decks and porches are often add-ons to the original home. Many of them have been poorly built by weekend warrior homeowners or handyman-type contractors. So, the first question to ask is, who built the deck?
The image above depicts a cantilevered deck. Joists should be cantilevered no more than 1/4 of the joist length, or 3 times the joist width, nominal depth, whichever is smaller.
So what they're saying is, let's just say this floor joist here is 12 feet, all right, total length. So if I take 25% of that 12 feet, then we're looking at 3 feet. So this cantilevering is from this point here, and this should be no more than 3 feet where it comes into. 25% of whatever the overall length of the floor joist is.
Home inspectors should take note of sagging rafters, sagging roof sheathing between rafters, sagging or crooked ridge board, leaking gutters, and roof spreading. Roof spreading often pushes out the middle top of the exterior walls.
So for this, you're going to want to, get yourself at the end of the house, and you sight down the house. And if it looks like the walls are being bowed out, or maybe we'll have a sag in our ridge beam, those are all clues that the structure of the roof is being well, it's weak. It's being pushed out. It's moving. All right, and you figure the weight of the roof and snow and everything they'll set on here, it's all a triangle. So all this pressure is going to be pushing down on the top. If we don't keep these walls down here, if we don't keep that bottom from being pulled apart, well, then it's just the weight of it itself. It's just going to start pushing everything down. So you end up seeing gaps along the ridge board and where the rafters meet. And then you're going to start seeing bows in the walls. And again, this is just call it out. It's not our problem. We don't have to give somebody a solution to fix it. We just need to let our clients know that it exists. Plain and simple. All right, this is the last slide for this one. Please take the quiz, and then we got one more presentation on structures. Thank you.